this tutorial I'm going to show you how to graph this polynomial, x cubed times the quantity x plus 2 times the quantity x minus 3 squared. So the first thing that you need to do is take a look at when this polynomial would equal 0, what all the different zeros would be. So one way for this polynomial to equal 0 is if x actually equals 0. And we can see that right here. If x were 0 in this case, 0 times whatever this is times whatever this is, you would still get 0. So x equals 0 is one of our zeros. X equals negative 2 is another 0, and we can see that from this part right here. And then x equals 3 is another 0, and we can see that here. So what we're going to do, just to start off, I'm going to plot all of these zeros. So when x equals 0, we put a point. When x is negative 2, we put a point. And when x is positive 3, we put a point. Let's first take a look at the end behavior for this graph. So the end behavior, and this is something that we discussed a little bit in class. The end behavior, you really want to look at your leading coefficient. Now in this case, this polynomial was given to us in a factored form, but you could picture what this would look like if you were to multiply it out and expand it. So if you were to multiply this out, we have x minus 3, the quantity squared. This would become x squared minus 6x plus 9. And you would multiply that by the quantity x plus 2 and also by the quantity x cubed. We can see that as you would FOIL through, this quantity would become x to the 4th plus 2x cubed. And then it would eventually get multiplied by this polynomial over here. The end result, really what I'm looking for here is what is the leading coefficient and what is the degree of the polynomial. So when I go through and I multiply, I'm not even going to multiply all of it. All I need is that x to the 4th times x squared over here. We're going to end up with x to the 6th power with a leading coefficient of 1. The fact that this is an even number, a 6, that means either both ends of my graph will be up or both ends will be down. Then we take a look at the leading coefficient. This is a positive 1. The fact that it's a positive 1 tells me that the ends for this graph both are going to be up. So we're looking at this scenario here. That means I'm expecting for my graph, and I'm just going to kind of put them off to the sides, it's going to end up on both sides. So it's just a question of what's happening here in the middle. The next thing I want to look at is the multiplicity of each of these zeros. The multiplicity means in factored form, how often does that 0 show up? So for 0, it shows up 3 times because we had x cubed. You could think of that as x times x times x. Then we have x plus 2, so negative 2 that showed up once. And then the x minus 3, that's the quantity squared, so it's x minus 3 times x minus 3. That means it shows up twice. When the multiplicity is odd, like these problems here, that means the graph actually crosses over the x-axis at those points. So it's actually going to cross here at at 0 here and at negative 2. I'm expecting the graph to actually cross. So since I'm expecting end behavior up here, I'm thinking it's going to go down, cross over the graph here, cross over the graph again. So I'm going to be on the upside. But over here I have another 0 and I'm supposed to end up over here. With a multiplicity of 2, that means the graph, it just bounces off of the x-axis at that spot. So I'm expecting that it's going to go down here, cross over, it's going to come up some amount, we don't really know, and then when it comes down it bounces off of that and comes back up. Now we could actually go through and evaluate different values in the middle here. For example, I could plug in 1 here. Well, when I plug in 1, that's going to be 1 times 1 plus 2 is 3 times, well, 1 minus 3, that's negative 2 squared is 4. So it looks like this is actually going to come up a lot more than what we thought. It's going to come all the way up to 112. The only way that you're going to know that is by plugging in values. If I were just asking you to do this on a non-calculator part of a test, I would say plug in a few here and there. So we can at least say, all right, I know that this goes all the way up here down. Obviously, yours is going to be much nicer than mine. You could plug in -1. So that's going to be -1 times, well, -1 plus 2, that's 1. So we're up to -1 times, and then -1 minus 3, that's going to be -4 squared, that's going to be 16. That means this part is going to go all the way down here to -16. So basically what it's showing us is this graph is stretched out a lot more than maybe we thought. So instead of having this little part here, it's going to be stretched out a lot more. But in general, this is all it's really asking for, is can you figure out when it's above the graph, when it's below the graph, and at all of these zeros, does it actually cross like it did at -2 and 0, or did it just bounce off like it did at 3? And that has to do with the multiplicity. So really that's all you need to know about graphing polynomials.